Hello everyone, thank you very much for joining me again for this remake of the Spring Security Fundamentals series. This is lesson number 1. I'm so happy to be here with you again, and I'm so happy to see that so many people are already here waiting for the event to start. I can see you have already discovered the live chat, so if you want to ask questions or start discussions in the live chat, that's why the live chat is there. So that's what the live chat is for. So I do encourage you, use the live chat, and if you watch the event recorded afterwards, don't forget that you can always ask questions in the comment section of the video, and you can anytime find me on LinkedIn and Twitter, of course. So for those of you who don't know me, this is my YouTube channel for a long time already. I think I've just went over 10,000 subscribers, and hopefully you are one of them. And a lot of people know me for writing this Spring Security in Action, who was my first out of the 3 published books with many publications. But you know, the problem with this book is that at the moment, even if about 80% of it is still good, it's still good information, good examples, many things changed in the past more than a couple of years. So it's actually more than 3 years since I've started writing the book, and more than a couple of years since it was published. And a lot of things change, and Spring Security has changed a lot. Spring has changed a lot. Spring Boot has changed a lot. So that's why I decided to create a remake. I had to take the decision between just replacing the parts that are obsolete or creating a full new series, and I decided to create a full new series because this way I hopefully give you the chance to join here with me live, ask questions live, start discussions. And I see, hi everyone, I see your messages. I always keep an eye on the live chat, and I hope that you will ask all your questions during the event. So this is just the first time, this is just the first lesson, and I will take it slowly. Maybe some of you who already followed me know some things about Spring Security. I apologize to those who already know these things, but I want literally to take it step by step again, to give everyone the chance to learn everything, ask their questions, understand properly how to use Spring Security. And that's basically how we will do. I will just start from the very beginning with what Spring Security is. I will create the first example. Today with you we will create basically the simplest example. With Spring Boot I will explain how it works, and then lesson by lesson we will go into more and more complex details, finally going again into OAuth 2, OpenID Connect, creating your own resource server, creating your own client, creating your own authorization server, reactive applications, testing Spring Security applications. And I expect there will be a lot of questions throughout this entire series of lessons, and I expect there will be a lot of lessons, because if I remember correctly, the last series had about 30 something lessons, so I don't expect to have less than 30 something this time as well. So that's basically what we will do in this series of, say, 1 hour lesson per 1 hour lesson per week. Hopefully I will be managed to do that. And let's just start. And I have also a new toy with me here, so I would like to use this new toy instead of previously I was using Inkscape. Now I can theoretically draw everything myself while I speak, and then of course I will use my IntelliJ to write all the code as I used to do. So first of all, I would like you to understand that Spring Security is about application level security, and that means 2 things. So it's authentication and it's authorization. Okay, so hopefully you see everything that I write. So these 2 pieces of information, it's what we call application level security. So app level security. And I say that because security is a very, very large concept. It's basically from the network, so in terms of communication, from the network layer to the infrastructure layer, operating system. If you use containers and orchestration at the platform layer and containerization, service mesh layer in case you have, and then application layer is basically what kind of logic we build inside our application that is related to security. So we will not discuss about the whole thing security is, because we would actually need a life for that. And I don't even think that someone who really knows everything in security, because there are so many things to discuss, process level security and so on. We will discuss here only how to apply application level security, and we will discuss that with using Spring Security, which is the first framework, and in 99.99% of the cases the framework that we will use with Spring applications. And Spring is that large ecosystem in Java we use to build many applications. A lot of applications today rely on this framework, on this ecosystem of frameworks that we call Spring, and that's why it's very important you learn Spring Security, because this is basically the de facto framework you will use to secure your Spring applications. So that it's very likely you will build Spring applications if you are a Java developer, and it's very likely that if you build Spring applications to use Spring Security to secure them. So that's why we discuss, and authentication is basically the logic in your application that decides who is the user trying to do something. So when someone tries to use some kind of use case, the application tries to figure out who is that user. And there are many ways in which this can be figured out. So the easiest way that we will also start with in the first lessons is using some credentials like username and password. But you of course need to understand that it's not only a set of username and password credentials is not the only option. Now you can use some kind of hashed fingerprint, you can use some kind of certificate, and there are even more complex authentication and authorization flow that implies more steps for authentication, for example what we call MFA or multi-factor authentication, and so on and so forth. But the whole idea is that first of all, authentication is when the application tries to figure out who you are. And then there is the second step, authorization. So in theory, this sounds very simple, isn't it? Because what we will discuss throughout these many lessons, it's only a two-steps process, isn't it? It should be very easy, but as you will see, even if it's only a two-step process, there are so many things to understand to properly configure your applications that at some point it becomes more than an intermediate subject. So in case, in this series, I will assume that you already know the Spring fundamentals at least, and I will not in many cases go over the basics again. And if you don't already know Spring fundamentals, then what I will recommend you is try to learn first the Spring fundamentals, and for that you either have my Spring fundamentals series on this same channel, a lot of lessons still for free for you, as they will always be. And of course, if you would like a book, my recommendation is, of course, my first recommendation will be subjectively speaking, the book I wrote, which is Spring Start Here. But that of course costs some money, and you can find, because I see a question, where do you find my books? You can find them either on Manning.com, either on Amazon, and on another some other many bookstores, online bookstores, depending on the country you are living in. So you just search them on Google, you will find many options to buy them. So that basically we simply the application finds out who you are somehow, either it's a set of credentials, your fingerprint, something else, a certificate, and then it's authorization, where the application decides if you are or not allowed to do something. So if you are the boss, then you can do something. If you are not a boss, then you maybe are not allowed to do anything. I don't know. The idea is that authorization, the whole thing about authorization is just a decision the application makes based on who you are, and the rules is something you need to configure, which means you might even have an application where you don't need, in some cases, to authenticate at all, so that means you don't apply any security rule. Or you can say authentication is enough, so if the application knows who you are, there are no other rules. Authorization only implies the application needs to know you, so a successful authentication. Or authorization might mean you have specific authorities, or you have specific roles, and that's where we have two essential concepts that we will discuss: the one of authority and the one of role, which basically behind the scenes, as you will see in Spring Security, they are very similar. They basically technically represent the same thing, but theoretically they are different concepts, where authority is something you have, so this is have here, something you have, while role is something you are. So see, this is verb to have, and this is verb to be. So you say, I have an authority. I have the authority to read, I have the authority to write, I have the authority to delete, to change, to something. So it's something, usually it's an action that I can do. I have an authority to do something, while the role, it's a badge. It's just a way to say I am someone. I am an admin, I am a boss, I am a manager, I am a user, I am a client. I am someone, and based on who I am, I will be granted permissions. So you can see it's a very, very simple difference between authority and role. And behind the scenes is just a conceptual difference between them. And technically speaking, you will basically even see that they have the same contract behind the scenes, a contract that I will tell you later about, but as an idea is called granted authority. So granted authority, very ugly my writing, sorry for that, but you will see it in code anyway, is what we will learn to be the interface behind the scenes that represents both roles and authorities. So that's basically what we are learning. We are learning to use this nice framework called Spring Security to implement authentication and authorization. And before starting with the first project, because of course I want to show you code, I want to show you how to use Spring Security. In the end, my purpose in this stream is, after all these lessons, you to be able to properly use this framework, and that definitely means writing code. I want to make sure that you understand the theory behind the scenes. So the idea is that there are two ways in which Spring Security allows you to define the authentication and the authorization rules. And mostly in case of authorization, authentication is basically more than two, we will discuss, but you will apply them in kind of the same way. So we will have different options, like using HTTP basic, which will be the first way we will learn to implement. We can use certificates, we can use complex authorization flows like the ones using JWT, which is basically OAuth 2 flows, and so on. And then you will have authorization, and in case of authorization we will discuss about web apps, but we will also have the possibility to apply authorization rule in non-web apps. And in web apps, the first way in which you can apply the authorization rules is HTTP filters, while in non-web apps you only have the options to implement the authorization rules using aspects. Aspects can be used with web apps as well, but with non-web apps you cannot, of course, use HTTP filters, because HTTP is a concept strictly linked to web applications. So let me see, already you have some questions. I see a lot of discussions I will post from time to time. I will read your questions, try to answer them now, and then I will start creating the first project. So the first question, do you play the piano? Yes, I do play the piano. Then where can you buy your books? I already answered that. You can just Google them and you will find them in many places. And then, okay, how is this course different from my Spring Security course that is registered a few years ago? As I started with, there are things that have changed, and now I will basically update everything that changed. You will see, even today I will show one of the differences, so stay tuned. The web security configurer adapter that you might have already learned if you follow the first 10 lessons is now deprecated, but no worries, only that is deprecated. Everything else you learned is still good. Yes, this is a remake of the Spring Security playlist, but enhanced, of course. Then we have JDBTD is the strongest authentication authorization method, right? I wouldn't say so as the strongest. It's a different authentication process. It's basically JVT. First of all, it's just a token implementation. It's not an authentication method. Secondly, it's not necessarily the strongest, but to allow me explain it better, let's just take it step by step, and when I reach that point where I will discuss OAuth 2, I promise you that I will teach you what JVT is in detail, so you will know very well. I will make sure you will understand very well what JWT is. Is this beginner friendly for students? Just Spring knowledge? Yes, Spring knowledge is everything you need to understand Spring Security, so it's the only prerequisite. You know Java basics and Spring fundamentals, and if you don't know that already, you can always find them still on my channel. With that being said, I think we can already create a new project. And let's start with the simplest, hopefully, application. Mind that I'm using an IntelliJ Ultimate. If you are not using IntelliJ Ultimate, as you might know, you will not be able to use Spring Initializer, but you can use either a different IDE or directly go to Spring, start Spring.io website and download the archive from there. Spring Security 2022. Lesson 1, I will say just C1, example 1, because maybe at some point we will have multiple examples. I'm using Java 17, which happens to be today the latest long-term supported version, and I will definitely use the latest Spring Boot, which at this time is 2.7.2, but we expect 3.0 to appear somewhere in October this year. And what do I need is the web dependency and the Spring Security dependency, and that's the only thing I need for the moment. I will start with the simplest of the examples, and then I will progressively make them lesson by lesson more and more complex. So that's what we need. Most of my examples in this series will still be web applications, because even though Spring Security can be applied without in non-web applications as well, well, I will anyway teach you with web applications also those approaches, and 99% of the cases most likely you will need to use them in web applications. So that means web applications should be enough in our examples. So let's just create a project and see what happens if I only just start now this application I just created. So you see that I didn't even do anything. I only created the application, but we know that we are using Spring Boot, which is that Spring ecosystem project that implies the convention over configuration approach. What does that mean? It means that Spring Boot, based on dependencies we added, have already configured our application somehow. And we have added two dependencies, the web one, which will make sure to configure for us a Tomcat, a servlet container, and everything that's needed in terms of the Spring MVC design architecture. So it will configure for me the dispatcher servlet, it will configure for me the view handler, it will configure for me everything I need to have my HTTP requests translated into some controller method calls. And because I have added Spring Security, that's one of the things that I did as well. What Spring Boot will make is it will make sure it shows me the simplest configuration for Spring Security, which means that I can already test that my Spring Security works properly without even doing anything. Of course, it's never in a real world scenario that you will simply leave it like this, because you will see this configuration, this convention configuration, it's only for the testing purposes, for demo purposes, to make sure that the dependency works right and has been configured right. But what you will learn is how to configure it for practical applications. What is the tool I use to write is Remarkable. So that's my tablet here I'm writing on, and you saw it on the screen. When you can expect my next book? I kind of will start the second edition this fall, hopefully somewhere in October, I don't know, so maybe by the end of the year you will already have some chapters. Okay, I'm not going to write any code. I'm simply keeping my Spring Boot project, and what you can see in my POM XML file, the only couple of dependencies I have is the Spring Web and the Spring Boot Starter Security, and then the other two which are test related, but for the moment we are not writing tests, so you don't have to care about them at all. And the only thing I want to do now is simply start my application. So let me start the application and see what happens, and while it's starting I can still read your questions and answer them. So we need first to understand how servlet filter work before understanding Spring Security. I don't expect you know how a filter work, because I will in this series give you the minimum needed knowledge for that. But the more you know about Spring, the easier will be for you to understand Spring Security in this series. Will you cover OAuth 2? Yes, I will cover, but somewhere that will be somewhere more weeks from now on, so somewhere after the half of our playlist, because OAuth 2, it's already an advanced topic. So as you can see, I am starting step by step to give everyone a chance to learn. Okay. And yes, I will explain with diagrams, because that's why I took my Remarkable here, to make the diagrams easier. Good, I see everything is started now. And what can you see? You see that the application started, so you can see it. It started fine. It's a web application. The default port a web application starts on is port 8080. We can see it started in about 7 seconds. And this is a using generated security password, and it gives me this password which looks like a unique identifier. It is actually a randomly generated unique identifier, but they also by the time added this message that tells you clearly the password you have here, it's only for development use. So what you will basically learn is how to create your own password management, your own credentials management. You will never in a production application use this password, but with this one, which is the pre-configured approach with this password, we will be able to see that everything works fine. But we can't test anything unless we have at least one endpoint, because what do we actually secure in a web application? In a web application, we secure endpoints, which are sometimes also referred to as resources. So resources, when you hear about resources in a web application, it refers usually to the endpoints through which the client calling the server can either get data or can change data on the server, and it's a generic term is resources for that. So in order to test anything, we need to have one resource we secure. We secure the resources, we secure the endpoints. So let's create a controllers package for that, and the simplest endpoint just to have something that we can secure. So let's call it demo controller, and then we know that what we will do is annotate this with REST controller. By the way, all my lessons will be on GitHub later, so you don't have to rush on writing the code with me. You will have it after the, I will share a link for the code I'm writing after the video is recorded. Then let's say public string hello, and the only thing I'm doing here is I'm returning hello, and then I will use the get mapping annotation to specify the path. So let's say the path is hello. So finally, this is a resource, and if I'm restarting the application now, I can call this resource. But by default, all the endpoints, all the resources are secured. So if you don't change anything in your Spring Security configuration, the endpoints are all of them secured with exactly that random generated set of credentials. So that means that if I'm now, for example, opening a Postman to make a call, to execute a call, I will only see that if I don't provide the right credentials, I will get a 401 unauthenticated, meaning you need to provide credentials if you want to call any resource on this application. So let's try first to call the hello endpoint without providing the credentials, and then let's provide these credentials that have been randomly generated. Actually, only the password has been randomly generated, and we will choose then how to generate our own credentials. We will learn that. So this is my Postman, and what I'm doing here, I'm executing a get with HTTP localhost 8080, and the endpoint was, the path was hello. I'm pressing the send button, and then I get, as expected, a 401 unauthorized. And the reason I'm getting a 401 unauthorized is because I didn't provide any credentials. How do I provide the credentials? To know how to provide the credentials, I of course first of all need to know what kind of authentication, what is the type of authentication that Spring Security is pre-configured with by Spring Boot. And it turns out that by default, and it's basically expected, isn't it, is the HTTP basic. So HTTP basic is what we expect to use by default, and if we didn't configure our own kind of special authorization, special authentication method, then it will be HTTP basic by default. And in case of HTTP basic, what happens is that in the HTTP header, we will have to use the authorization header, and we will send the credentials, which will be base64 encoded, as I will show you. But the easiest for the moment is just take Postman, like go to the authorization tab here, and then select basic authentication, and then provide the right credentials, which are actually the user will always be user by default, and then the password is the exactly self-generated one you get from the console. So I will copy this value, I will put it here in the password field, I will press the send button again, and then I get a 200 OK and hello. So that basically proves that basic authentication with those credentials really work, and that's what we expect, because that's how any default Spring Boot project with Spring Security is pre-configured. So it's pre-configured to use HTTP basic, and it has only one pair of username and password credentials, where the username it's always user, and the password it's always a self-generated, a randomly generated password that the project generates every time randomly when the application starts. So that's why it works for me now, because I use the right credentials. Good, that's fine, hopefully easy to understand by now. But we definitely have some questions, and let me clarify them in the right way. So first of all, I used Postman, and I only had to select basic authentication, put the credentials, and then it worked. But what really happened here? How did these credentials end up opening the door for me to call the hello resource? Well, this information has been sent actually on a header. So what happened here is that when in Postman I selected basic authentication, a header has been created, and usually it's hidden by default if you use Postman. So let's show the hidden headers. And this is the first one that you see here, which is called authorization. So funny thing, it's called authorization because it's basically used for authentication, but that's from the HTTP specification. It's from the very beginning, it has been called authorization, and this header is still used like this, even if it's used for authentication. So the authorization header contains the value that represents the key opening the door to accessing the resource. And you can see the format is basic, is the word basic, followed by a space, and then followed by this string which looks strange. If it's the first time you see something like this, it might look strange for you, but if it's not the first time you see, you might know this is a base64 encoding. And base64 encoding can be easily decoded using any kind of base64 decoder. So base64 decode, if we search on Google, you can get a base64 decoder. There are a lot of them out there. You can copy this this value that we took from Postman. You press the decode, and then what you see, it's exactly user followed by a semicolon, and then followed by exactly the password that I used in the authentication section of Postman. So what did Postman actually do is that it concatenated the username with a colon and with the password then, and the whole input has been base64 encoded and then prefixed with basic. So it's basic followed by a space followed by the base64 encoding of the username colon password. And that's how HTTP basic works. So that's how HTTP basic gets the credentials. Now it's a very important thing I would like you to remember is that base64, it's an encoding, not an encryption, and it's a big difference between what encoding means and what encryption is. And with that being said, let me go back to my remarkable here and try to, I think I can erase all this diagram now, say erase all, and I would like to discuss the difference between encoding, encrypting, and hash functions. So I find it very important for any developer to understand the difference between these three before they try to understand security. And if you don't make the difference between these two, you might then later find difficulties. Like for example, the password encoder. I see a question now about the password encoder. We will discuss it later. But you will find out later why is it that called encoder? Why is it not a password encryptor and it's a password encoder? Maybe you will have that question. But if you know the difference between these three terms, then you will also understand better some things that will follow. So make sure that you make the difference. Now, encoding. Encoding is only a function that it's always possible to reverse somehow. It might or might not imply the need of a secret. So that means that in case of encoding, it can be just a mathematical transformation that doesn't even need a secret to be known to revert it. So for example, if I have string 1, 1, 2, 3 or 1, 3, 4, 5, reversing the string, making it 5, 4, 3, 1, this is an encoding. It sounds strange, it's just reversing the string, but encoding, it's only a mathematical function that transforms an input into an output in such a way in which you can always reverse the output and find out the input if you know the rule. In my case, the rule is just read it from right to left. So it's very simple. Maybe the easiest encoding, or the most popular encoding is, I think I forgot the name, but it was the idea of having A, B, C, D, E, all the letters of the alphabet, and then have randomized them behind. So for example, you have Z, you have A, D, E, F, and so on. So now you know that the string, like the string B, C, E, D, in this case will be encoded to, and you just take the one behind, you know, so it's A behind, and then C has the D, and then E has the F, and then D has the E. So this is a transformation, but you can always go back from the output to the input, and in an encoding you don't even need to have a secret. Caesar cipher, thank you very much, Eduard. So that I didn't remember the name now, but now I remember it. And this was a popular way, if I correctly remember from my very poor history knowledge, this kind of a cipher was used to send messages in the early ages. Exactly. So that's basically a very popular but very simple, and always the first example in what encoding means. But what you should observe is that encoding is only a function of transformation from an input to an output, and can be always reversed. Did you see how I managed to reverse my base 64? So I just took it. I didn't need anything because base 64 is just an encoding. So I put the output, and this transformer, this decoder, immediately could transform the output into the input, just because it knows the rule of base 64. I don't need any secret. What is the difference between encryption and encoding? Well, when you say encryption, then it means you are transforming an input into an output. But to go back from the output to the input, you always need a secret. So no, not everyone is able to find out which was the input after an encryption function. So what you can say about encryption is that it's a more particular way of encoding. Encryption is still a transformation function, so it's a particular encoding, but it implies that you always need a secret to go back to the input, and this secret is something that not necessarily everyone knows. So you see, when you say encryption is a transformation that assures you that not everyone can find the input out of an output. So if I have an encoding, a normal encoding, like the Caesar cipher, and I have the output, the only thing that I miss is the rule, but if I have the rule, then I can anytime go back to the input. So the only thing I can hide is the transformation rule. That's the secret. But if I have an encryption, then I literally need a small piece of information, usually also referred as the key, and without that I can't go back. And that's the difference when we will use the term encryption, and I will then definitely give more details about that, because you will see we have the possibility to have symmetric keys, asymmetric keys. I won't now go into the details because it's just the first lesson and I won't take it step by step. But the only thing I want you to remember is now the difference between encoding and encryption, and then, of course, hash functions. In a hash function, from an input, you can always go to an output, but from the output, you can never, by any means, find the input again. So one of the first rules of hash functions is that going from the output to the input is not possible. But there is a second rule of a hash function that's very important, and without which a transformation is not considered a hash function. And that is, you can always say, if an input, if you have the input, you can say that an output, a specific output, corresponds to it or not. So if that's the output that has been really generated at some point by this input. So you can't go back from the output to the input, but if you have the input and the output, you should be able to always say if the input and the output are related one to the other. And that's a very important second rule that makes a transformation being a hash function. And usually hash functions are the preferred way to store temporarily or permanently passwords. So very often we see passwords being hashed because the first rule of hash transformations assures us that if someone steals the password, the stored password, they cannot find the input. But it allows us, if the user knows their password, to validate that is the right password with the one that we stored in memory. So that's why a hash function is very, very relevant. Again, I will come back to this later when we discuss more details about hash functions. So let me see some of your messages that came here after this. One of the simplest and most well-known encryption techniques. So still qualifies as encryption for most likely the hidden rules. No, I wouldn't say it's an encryption, Edward. From my perspective, it's not an encryption. I don't care what it says on Wikipedia and stuff like that. From my perspective, it's an encoding as long as you don't have a secret. I know you can maybe argue that, consider it an encryption just because you might say if you make the rule a secret, but nah, I'm not sure what to say about that. Let's just count it as an encoding for the moment and say that for an encryption you really need to have a key that is stronger than just knowing the rule. And then say if the it is public key cryptography. Actually, what I've shown here with a secret, if you have only one secret, is called private key. But again, up to the keys, at some point we will discuss that more in detail. So let's leave it for later. Whenever I hear hash function, MD5 comes to my mind. That's a very good point. MD5, it's actually a hash transformation. Well, it's not. It's deprecated. It's recommended not to use it anymore. You will find out that it's actually deprecated because now there is a possibility to go from the output to the input, which doesn't make it a hash function, a real hash function anymore. But during many years, MD5 has been used. It has two problems. First of all, is that mathematically speaking, it has been proven. I think it was someone from China, if I'm not wrong, but I might be wrong. I have to refresh my memory, who proved that many years ago. It was more than 10 years ago when this was proved, that you can mathematically find a way from the output to the input. Secondly, you will see that MD5, but I will again discuss this later more in detail. Always from the same input you will have the same output, and because of that you can create what we call rainbow tables. Rainbow tables is when you store the output of an input of a hash function, so then you can search for the output and find the input, and this is considered to be a strong vulnerability. Today we do not use any kind of hashing function that always produces the same output. We do use hash functions that are salting, we call the output, meaning that they produce always a different output, but still give you a rule to compare the input. But because they always produce a different output, these kind of rainbow tables are not possible anymore. So it's that one of the things, but I will come back and I will maybe repeat some of the things. I'm pretty sure at some point I will repeat some of the things we discussed. And then we can only have one hash function. It should be unique and not the same two hashes. This is called hash clashing, and mathematically speaking it's possible. At some point you will see that you might have the case where you have duplicates, but yes, theoretically speaking that should be not possible. Is HTTP basic always use base64 encoding? Yes, it's all that's by definition. So it's by the specification of HTTP basic. You can find on the internet the RFC and read it. It will always be HTTP basic encoded, the set of credentials. That's why you never use HTTP basic outside of HTTPS. So in a normal, anyway, in the real world, you should never use HTTP anymore anyway. So you should always use HTTPS to make sure that what you send on the wire is encrypted, because HTTPS encrypts what you send on the wires. That's very important. Otherwise, by default, nothing assures you that what you send is encrypted. So of course we will use local HTTP, but remember that in a real world scenario you should always use HTTPS. Fine, and now with that being said, we can even go back here, and you see that I only have 14 minutes, so I was sure that it will be a first light lesson, but I still want to show you one very simple thing, and that is how do you create your own set of credentials, and that's most likely what we will extend in the next lessons. So yeah, I will show you now how to create your set of credentials. Then I will show you basically the architecture for authentication, and then I will even show you how to implement different ways of generating the credentials, like communicating with a database and taking the credentials from a database. So today, however, it will be very light. I will show you the first configuration, and it will be the only one for today, how you create your own user detail service. And user detail service, what you need to remember is that it's that component that manages the user details. So it's the component you implement in your web application to tell Spring Security where to get the credentials from. So I will create something called web security config. The name is irrelevant. You can name your configuration class whatever you like, and then of course you need to annotate it with the @configuration annotation, which makes it a configuration class in Spring Boot and in Spring. And then you will add a bin to your context of type user detail service, which is the contract, is an interface that defines the contract of that object Spring Security understands as the manager of the user credentials. So basically, in this contract, the only thing you have is a method that gets the username, that unique identifier of the user, and provides the user details in this nice user details shape, which is again a different contract. which is the contract that Spring Security understands as being the way the user details are presented, meaning everything the application needs to know about the user. So what I will show you how to do now is I will create a user detail service using the simplest implementation Spring Security provides. It's called in-memory user detail service, which I will return. And then I will create a static one user of mine that I will put inside this in-memory user details manager. And that's very easy to do because Spring Security provides us a class named user with a builder approach. So I can name it Bill. I can say it has password 12345, and then it's mandatory they have an authority, which, remember, is either a role or an action that the user is able to do. And then later on, probably in the next lesson, you will learn why this create user is needed to define the user. And then it is this couple of getting the user's details and then managing the passwords. And for managing the passwords, we will use a component named the password encoder. And again, today I'm only showing you how to add the simplest password encoder, which is actually even a methodic password encoder, so we don't use it in real world apps. You see it's cut out with a line because this is a password encoder that basically doesn't encode, so it's never recommended to use it in a real world app, but you will very often find it in examples, and that's why today we are using it as well. But with this very simple configuration, this is the only configuration you actually need. And now if I'm restarting my application, I will be able to prove that using Bill and 12345 I can call the endpoint. So I'm starting the application. I have to wait a bit for everything to start. Here it is. Observe one important thing. There is no more randomly generated password. Do you see that? So you see in the whole logs previously, if you go a few seconds ago, it was that unique identifier randomly generated password that we were using. Now it's no longer there. And the reason it's no longer there is because if we created our own user management, then we don't have, Spring Boot don't provide us anymore a randomly generated one, because it wouldn't make sense to have a randomly generated one anymore. But that actually means that in the authorization now, instead of using this, I literally need to use Bill with 12345 send, and you can see the result is still a 200 OK. So that's how it works. And yes, I know it might look difficult for you now if it's the first time you see that, but I promise you that you will follow the steam. I will literally use step by step and prove everything. So I have more questions, and I want to clear this and discuss what we did, and also answer your questions before we end this session. So if we have more than application on the same server, which recommended install SSL certificate on each app or install one at the domain name. Let me take this one as an infrastructure, and it's unrelated to today's lesson shortly. It depends is the answer always, but let's take that one later when we have like some more details, because I don't want to mix too much information that is outside of the lesson now with this lesson. Can we create our own password encoder? Yes, you can create. Actually, this is not something you will likely do. You will not likely create your own password encoder. Actually, as you will see later, you have the possibility to use many password encoders that are already very, very fine to use, like the bcrypt or the scrypt password encoder. So for example, bcrypt is probably the most used one. Yeah, let me go back now to the no password encoder actually. But to create your own password encoder, and we can even try that in the next lesson if you want. The only thing you need to do is to implement the password encoder contract that I will detail in the next lesson. It only has two methods in the contract. I see two methods in the contract because the third one is a default one, so it's not part of the contract. And what you need to basically define is how do you encode, and the matches function, which is how, by having the input, can you match it to an output. Okay, let's take this one in the next lesson when time comes. So I now only wanted to show you the simplest example for today. And then why would you do that when there is already industry standard encoders provided by Spring? Well, okay, I think that's basically a question for the previous question. Yeah, it's basically why at some point maybe you want to create your own password encoder. Like, yeah, indeed, as you will see in the next lesson as well, there are plenty of password encoders. Some of them are deprecated, where like the message digest password encoder was the one using MD5, for example, which we just discussed. It's not used anymore, and so we have password encoders that we don't use. But we also have already bcrypt or scrypt or ppkdf2. We have a lot of password encoders that already implement some standard encoding ways. But hey, why not, if we want to create our own password encoder for some reason, like maybe, for example, we want some specific kind of keys that we need to use and we don't find one that's already provided by Spring Security, then it's very easy. The only way the only thing you need to do is implement the password encoder interface, override and define the encode and the matches method. And I can show you in the next lessons how to do that. It's very easy, of course, with a very simple example. So yeah, and that's basically, I still have 5 minutes, and with that being said, I want to actually show you what we did here, which will give you a teaser of what we will do in the next lesson. So what we basically did is that we have this nice application. It's a Spring Boot application. So let's say this is my Spring Boot application. And inside the Spring context, we added a bean, which is a user details service. And then we also added a bean that is the password encoder. And what you don't see here is that we replaced these beans, but they are already plugged into an existing architecture that we will detail next lesson, which, being a web application, starts from a filter. So this is a filter, as the filter that implements the HTTP basic authentication, which actually delegates this to an object called Authentication Manager, which delegates this to another object that is called Authentication Provider, which actually uses the user details service and the password encoder. So we only saw these two beans because all the others were still pre-configured by Spring Boot. So that's why you only had to define this. But what I'm going to tell you, what I'm going to teach you in the next lessons is not only how to replace this, it's also how to define this where needed and how to customize whatever you want from the filter to the authentication provider and eventually to the username and password. So I started just by showing you the simplest example. We didn't even do a lot. Next time we will still continue to discuss user details service and password encoder, but then progressively progressively we will learn how to define our own filter. You will learn this is part of a filter chain. You will learn that there is a security context where the authentication goes after a successful authentication. You will learn that you can create one or more authentication providers, which are the objects basically where we define the authentication logic. So it's basically where Spring Security says if the username is correct and the password is correct, then the authentication is right. But at some point you might need to create some other custom ways to authenticate. So that's basically how what we will do. Cool. Share the diagrams. Oh my god, I deleted the diagrams, so I didn't think about that. Next time, sorry for that. I didn't think that you want, but you can print screen them. You can just go to YouTube, go and enlarge that and print screen, so it's very easy. I don't have them. I just erased everything, every page I completed, but it's very simple. Just print screen the diagrams if you need them. Cool. The video remains registered forever. Questions in the comment section, guys. Thank you very much for being here, so many of you, and leading so many discussions and asking so many questions. I'm looking forward next lesson to see you again. Time is over for today, but we already discussed a very first very interesting start, hopefully. And I'm looking forward to seeing you hopefully next week for the second lesson and continue our discussion on the authentication framework in a web application with Spring Security by detailing the user details service and the password encoder more. So with that being said, I'm waving goodbye to you. So let me do like this, so show you my my whole face and my appreciations. And talk to you next time when we discuss next awesome things. Until then, have an excellent time for learning and talk to you later. Cheers, bye bye.